Okay, so yesterday, or last time we were here, we talked about multiplying algebraic terms, right? Remember that all terms have exactly how many parts? 4 parts. What's the first part?
Sign.
The sign. So if the sign is the first part, we always do the sign first, right? And for multiplying and division, the rules for the signs are the same. If the signs are the same, the answer is always a positive. Excellent. If the signs are different, the answer is always a negative. Good. Okay. Then we said that we multiplied the coefficients, which is the number part of a term that it's the coefficient is always the number part. Then we kept the base, and what did we do to the exponents?
Kept them too.
Added them. We added them together.
Wait,
yes.
Okay. We didn't do any with exponents.
Okay, there might not have been any with exponents,
we just wrote it down.
but we had the notes for it. Okay? So today what we're going to do is we're going to look at division. Now when you think about division and multiplication are related. They are opposites, right? So you're going to think of doing things a little bit differently with division. Now, because division with algebraic terms is still probably pretty new to most of you, we're going to do it using expansion, but there is a shortcut rule, and I'm happy to show those of you who want to see it later. But for now, we're going to go through the whole process because you need to understand what's really, really happening. All right? And the first thing I don't know what that's all about. The first thing I want to talk to you about is this. If you take anything and divide it by itself, what do you always get? 1, right? Anything divided by itself is 1. Because remember, now we're used to using our multiplication facts, and that does our division for us. But way back when you first learned division with beans or tiles or something, whatever you did, you learned that you could separate things into equal piles, right? And so division really means how many times will this thing fit into this thing? So for example, 8 divided by 4. How many 4s can you put into an 8? 2. So that's why the answer is 2, right? So we forget what division really means, and we start thinking about it as just using our multiplication facts backwards, right? So be careful and think about what it really means. So here's something very important that I want you to write down. Anything. What does anything mean?
Everything and anything.
Everything and anything. So did I just say number? No. Did I just say letter?
No.
Did I just say table?
No.
Actually, I said them all, didn't I? Anything. Okay? Divided by itself equals what? 1. No matter what. So, 5 divided by 5 equals what? 1. X divided by X equals what? 1. Shoe divided by shoe equals what? 1. It doesn't matter what it is. Anything divided by itself makes a what? 1. Now, another thing that we talked about is that you don't always have to write the ones, do you? Say I have 1y. Do I need to write the 1? Nope. We talked about that in our algebra conventions, that 1y is the same as just plain old what? Y. Okay? So be careful. So now, we don't always write the ones. We don't need them. So that should tell you something about it. If something divided by itself turns into a 1, do you always need to write that 1? No. Okay? So it's going to look like things go away. And the classic math word for this is cancel. I hate it. Because if you think of something canceling, that means it just disappears, right? It just goes away. It doesn't mean anything. But in reality, they don't cancel. they become what?
Invisible.
Oh, well, they become a 1. And do we need to write the ones, though? No. Right? We get to assume that they're there. Right, so they do become invisible. You're exactly right, but, okay? All right, so be careful. You're going to see the word cancel a lot. You're going to hear it a lot. But it's not really true. Anything divided by itself doesn't cancel. Anything divided by itself becomes a what? 1, and you don't always have to write the ones. Okay? So what we're going to do is we're going to look at doing the division using expansion. And that does mean you have to write a little bit more, but they know that here, so they keep the exponents, they keep the things very small. So let's first talk a little bit about indices. Say I have x to the 3rd power. What does that literally mean? We talked about this a little bit last time. It means x times what? No, not times 3, but times itself how many times? 3 times. And this is what I mean by expansion. Instead of writing it with an exponent, we're going to expand it out, right? And I want you to do this in your homework, and I'm including typing it into your Education Perfect, because you really need to get this idea into your head, or else it will come back to haunt you forever, right? And if you're going to be in my Year 9 class for sure, I don't want a bunch of people making silly mistakes just because they were too lazy to type in x times x times x. All right? So, what does g to the 2nd power literally mean? G times g. What does a to the 2nd power, b to the 3rd power literally mean?
A times A, B times B times B.
Yeah, a times a times b times b times b, right? Remember, when they're stuck together like that, that means there's a multiply between them too, isn't there? Okay? So you need to expand the whole thing.
Would there be any instance where would it mean multiply? Where
Never.
is one thing?
Nope, because if you have anything stuck together like that, it always means multiply. And an index or an exponent is the very meaning of it is a multiplier. So the very meaning of it is to multiply. Okay? Because if you have something like that, we're not talking about multiplication anymore, right? So if it has any other symbol in between, then it's not talking about multiply. All right? So, what does expansion mean? Expand it, write it out. You bet. Okay? Now, and that's what we're going to do the division. So let's talk about how to divide algebraic terms. And again, once you understand how to do it with expansion, then later you'll see that there are some shortcuts and rules. But again, knowing how to use a shortcut doesn't work if you don't know where you're going in the first place, right? Okay, so you need to make sure you know where you're going in order to be able to use a shortcut to get there. So we're going to do it the long way first, and then later you can do it. So the first thing we're going to do, though, is what is the first part of every term?
Sign.
So that means the first thing we need to do is we always need to determine the sign. Remember, and when you're dividing, same signs get you a positive, different signs get you a negative. Do you always have to write the positives?
No.
No. Okay? Is it wrong if you do?
No.
No. Right? So if you know that you make a lot of sign errors or signs are a weak area for you, then write the pluses and minuses all the time. Can't hurt. So second part of a term. The coefficient. And because we're talking about algebraic terms, the coefficients are always what kinds of things? Numbers. And so that's what we'll do next, is we'll divide the coefficients if possible. Because remember, unlike multiplication, you can't always divide. Right? 8 divided by 4, can I do that?
Yep.
You bet. 8 divided by 4 is 2, right? Okay. 2 divided by 4, however, can I divide it? Nope. But what can I do to it? Simplify it. What's it going to become? 1/2. Good. 3 divided by 5. Can I divide it?
Yes.
Can I simplify it?
Yes.
Nope. So 3 divided by 5 just stays 3 over 5. I do not want you to change them into decimals.
So if you can simplify it, would you simplify it?
If you can simplify it, you must simplify it. Absolute rule should have been beaten into you when you did fractions back when you were a mere child. Okay? Okay? Right? So, okay. What's the third part of every term? Yeah. And what we're going to do is we're going to keep the base most of the time. And you're going to see why I say most of the time. If you're not dividing it away, then it's going to stay. But if it's something divided by itself, the base is going to go away and turn into a what? 1. Which means it's going to go away, right? And the way we're going to know that is right here. Okay? What is the fourth part of every term? The exponent. Okay? So we're going to deal with those exponents by expand all exponents. And we just talked about what that means, right? So if you have x to the third, and we're not writing it like that, we're going to write it as x times x times x. Okay? Here, you already know the shortcut. I think I showed you the shortcut before when we did this the first time. All right, now, okay?
I forgot to tell you, I need to leave 5 minutes early.
No problem. Okay? All right, so everybody ready to see some examples? Then what I'm going to do is I'm going to go back to Education Perfect because I want you to see the examples they give you so you won't run into anything weird when you're doing your work, right? Because I need for you to feel comfortable doing this. Because most people, this is the weirdest one, the division. Division is always the operation that most people don't like as much anyway. So in this lesson, we're going to learn how to simplify division. Remember that when you're working with algebra, we typically write division not using the division symbol, but written as a what?
Fraction.
As a fraction. Good. So if you look at this one, for example, we have 3a squared b divided by ab. Okay. We're just going to take this in pieces. First, determine the sign, but it's a positive divided by a positive, so this is going to stay a what? Positive. Then we're going to divide in the coefficients, but you notice there's a 3 here. What number is in the bottom if there is no number?
1.
Be careful. A 1. And 3 divided by 1 just stays what? 3. Well, here's where it gets a little interesting, though. We have a squareds and b's and a's and b's. So we've got to work with those variables. For the variables, what we're going to do to do the division is we're going to expand them. So off to the side, a squared literally means a times what?
A.
And then what else is up there?
B.
A b. So that's what I mean by expanding it. In the bottom, ab just means a times what?
B.
B. And now anything that's identical, top and bottom, right, will turn into a what?
1.
A 1. So a divided by a here is going to turn into a 1. And there's no more a's in the bottom, so no more that a can't turn into a 1, can it? But b divided by b is going to turn into a what?
1.
Into a 1. Okay? I should have done that in a different color so you can see what I'm doing. I'm going to. So those became a 1. Those became a 1.
But isn't there?
Okay?
Oh no, there's not.
But what's left? So whatever's left is part of my answer.
I didn't get that.
So do the 1s just go away, or
Well,
where do they go?
What's really happening is you have 1 times a times 1. What's 1 times a?
A.
Times another 1 is still?
A.
When you multiply by 1, it doesn't matter.
So it basically just goes away.
So you're multiplying them, but when you multiply by 1, you get exactly the same thing you started with, so who cares? Yeah.
I thought you only put the 1 on one level. Like, you would only put it on.
He's just doing it to make you show.
I'm just writing that those two things turned into a big old 1. I won't do it in a minute.
What about the ones on the bottom? The A, B thing.
Well, those two A's turned into a 1.
Disappeared.
Those two B's turned into a 1.
You have to keep it because there's no other variable down there.
No, because if you have 3A over 1, what's 3A over 1? Just 3A. Yeah. There you go. So it is. So yeah, you don't need. You can. It's still there, right? But you don't write a 1 in the bottom. Mm-hmm.
But wouldn't there be like a fifth step to it then? Canceling out some of the variables.
Well, no. You just then you just divide away anything that's So you could say. All right, I can't get back to that page. There it is. Yeah. So what you can do is, yes, you just divide it out. So once you expand them, then you can use the division. So you can write that as a fifth step if you want to. Okay? All right. Now, let's look at another one. Okay? So we have, in this example,
Goodbye,
bye, just Jared. See you later. We have 2r divided by r. Well, that's the same as saying 2 times r over an r, right? Well, 2 divided, is there a number in the bottom to divide by? Nope. So 2 divided by nothing is just going to stay what? 2. R divided by r is going to become a 1. But I don't really need to write the 1 because 2 times 1 is still just plain old what? 2. And that's why many times they say it cancels. But be careful. They're not really going away. They're turning into 1s, but you just don't need to multiply by 1 because it doesn't make any difference. No, you'll be fine. And you're going to do so many of them, you're going to be so happy. Yeah. Okay, so let's look at this one. Okay? All right, ready? So we have 7xyz over xz. Right?
Why
What was...
did you cross A?
So you can see it's a z and not a 2. Y'all don't do that?
How could you?
When you have a 2 and a z,
But you.
just to tell the difference between, it's just an algebra.
We can tell.
Yeah.
Well.
If you write the 2 with a flourish thing.
Yeah, well, you'll just have to get over it because I can't not write a z without a line across it. It's an algebra thing. Mm-hmm.
On the board, the last sentence it says it's called canceling a variable.
Right, and I told you they're going to call it canceling, but I hate that. Because what happens is y'all will just start marking stuff off, and here's what's going to happen. Later, you're going to get things that are like this. And your tendency, if you learn it as cancel, your tendency is going to say, okay, well, those cancel. And that is absolutely wrong. Okay? So I know where you're going with it, so I really don't want you to use shortcuts like canceling if you can avoid it. I'm just trying to warn you that, yeah, it's great now, right? I can tell you it's canceling, and then you can just mark those things off. And then in 2 years, I'm going to say, oh, by the way, remember when I taught you canceling? It was wrong, and you can't do it anymore. Well, is it easier to learn how to do something the correct way in the first place, or to take a shortcut and then have to fix it later? I'm not good at breaking habits. Okay? All right, so let's go. So all of these are connected by multiplication. Do you agree?
Yep.
If they're connected by multiplication, that means they can be taken apart using, what's the opposite of multiply? Divide. So we can divide. So you see what I'm talking about? So what if I had like this? Is that all multiplication? Nope. So I couldn't divide any of it. Do you see? And that's where you're going to be going with it later. So, but because it's all multiplication, we can divide. 7 divided by nothing is just going to stay what? 7. X divided by x makes a what? 1, but do I need to write the 1? No. Y divided by nothing just stays what?
Y.
And z divided by z makes a what?
1.
But do I need to write the 1?
No.
So there's your answer.
Yay!
So you see, it starts to become easier as you get more exposure to it. But that's true of anything, right? Yes.
If you can't divide divided, do you have to do anything else?
Yes, there are some other steps, but you'll learn those later. Mhm. Yeah, you have to change everything. Okay? Yes. Of course. Okay? All right. Good job. So it's starting to look a little clearer now? All right. Let's look at another one. Let's do this one. So we have 3a squared. We did this one?
Yeah, we did that one.
Oh, okay. Well, then let's not do it again. I don't want to do it again. Fine with me. All right. And so they talk a little bit about what's happening here. Remember that anytime you have things multiplied together, the things that are multiplied together are called factors. Anything multiplied together is called a factor. So what are the factors here? Are 4 and a, are these multiplied together? Yes. Therefore, I have a factor of 4 and I have a factor of a. And factors can be divided away. And you learned largest common factor when you were reducing fractions, right? So say 11 over 33. The largest thing that will divide into both of them is 11, right? I picked this one just because you're going to see it later. And so you can divide an 11 out of both of them. And that's called dividing out the largest common factor. Is that how you learned to simplify fractions, using the word factor?
Yeah.
Okay, maybe. Again, sorry if you didn't. That's, I can't remember. I can't remember when you learned it because I wasn't here. All right, so here we go. So we have 4 times f times g. Do you agree? All I did was just expand the top. At the bottom is 2 times f times g times what?
G.
Times another g. All I did was expand the bottom. Now let's go back and divide. Positive divided by positive is a?
Negative.
Well, positive. Okay. 4 divided by 2 is? 2. F divided by f is a?
1.
But do I need to write the 1?
No.
Nope, because I've already got some stuff over there, right? G divided by G is 1. Do I need to write it? No, because it's already over there. But I'm still left with another G, aren't I? But where is that G?
On the bottom.
So do I write it on the bottom or on the top then?
The bottom.
It stays in the bottom, right? This time there were more in the bottom than there were in the top. So my completed answer, because I don't really have to write the plus, is 2 over G. So sometimes you can end up with more stuff in the bottom than in the top. And it stays in the bottom. Okay? How does that look? Okay?
That looks.
Hopefully good, because then they go to your homework. Now, but before we move on, before we just say we're done, though, I want to look at this section where they're going to start combining everything that we've done. Right? Now remember, if you have addition, subtraction, multiplication, and division, you have to use the order of what? Operations. You betcha. The order of operations. Okay? I want to remind you of something else that I've taught you that you may not remember. If you have two things if you have more than one thing in the top, or if you have any fraction for that matter, okay, remember that all fractions have a bracket around the top and the bottom. They're just always assumed to be there. Okay? So we just assume they're there. And if you can assume they're there, we don't have to say them, right? Okay? So if I have a bracket in the top, that means I have to do what? I need to do the math in the top when? First. Then there's a bracket in the bottom. That means I need to do all the math in the bottom when? First. Well, first or second after the other bracket, right? And then, what does the fraction bar mean to do? Then I can do the division, right? So to remember that even though they're not there, not written, they're there. Yes?
So, would we always do the brackets on the top first, or?
Typically it's top first, then the bottom, but you could do the bottom then the top. It wouldn't make the slightest bit of difference to the answer. Okay? Just get rid of the brackets. Excellent. Okay? Then you look for multiplication or what? Division. And then you'll add or subtract, but remember, we don't call it that anymore. We call it combine, right? Because they're not pluses and minuses anymore, they're signs. So it's combine. If the signs are the same, you keep the sign and add the numbers. If the signs are different, you keep the sign to the larger and subtract the numbers. So you're going to have all 4 sign rules built into this exercise as well. Okay? So, stay with me. Right? Okay? Plus and minus means collect like terms, or combine. I always say combine, but collect, combine means the same thing. Okay? So, always make sure you go slowly and carefully, following the order of operations, and look for things as you go. Okay? Here we go. So this one's going to look bad. It's not bad. Okay. First of all, what's the first thing I need to look for? Brackets. Do you see any?
Yes. But they're all wearing invisibility cloaks.
Right. So they really are there, but do you notice, even though that's 10pq, there's no addition or subtraction or anything I can do, is there?
No.
So that's why they don't normally write them. Okay? Now, what if it was 10 plus 7? Would I need the brackets then? Yeah, because I need to do that 10 plus 7 before. But do you see that that's all just one term, so it's not going to make any difference. All right? So, next thing you look for are exponents. Don't worry about this. You're not going to have any exponents to expand. You might have some exponents, but they'll be in the division, like we just talked about. Next, we look for multiplication or division. And remember, you look for them from left to right, just like you're reading a book. Okay?
You know how in Japan they read books from the other way around?
Yeah, but this ain't Japan. All right, so here we go. So, pardon?
What's number 3 again?
Multiplication or division, right?
More.
All right. So, multiplication or division. So, do you see any multiplication there?
Whoops.
The battery is running low.
Your battery.
Oh, well, we'll be done in a minute. Do you see any multiplication or division?
Yes.
Yeah, right here, that fraction bar means that's division, yeah?
But there's brackets first, so you have to do the multiplication
And then-
first.
Also, there's some multiplication right there, right?
There's
Okay. So which one do I need to do first then?
the
Doesn't
first
matter.
The first one you come to.
We're not.
It doesn't matter in this case, but it can. So the first one you come to, which is the division. So that's 10 times P times Q over 5 times Q, using our expansion model, which is what I want you to use. 10 divided by 5 is what? 2. P divided by nothing just stays what?
P.
Q divided by Q becomes a...
1.
And do I need to write that one?
No.
No. So there it is. Okay? Piece by piece. It's not difficult. Now we'll go to the next one. Positive times a positive is a positive. And because it's between two terms, I have to write the positive. You do not get a choice. And here we'll multiply. So we're taking 2p times 3. So 2 times 3 is 6. P times nothing just stays
P.
P. Now I've done the division and I've done the multiplication. The next thing I need to do is simply combine. And so I'm just going to bring down that minus P. Right? Because it didn't change. We didn't multiply or divide with it. Now what do you notice though? They're all what kind of terms? P terms. So can I combine them if they're all P terms? Yeah. Oh, be careful. Yes, I can. So 2 of them plus 6 of them minus, how many are here? 1 of them. So 2 plus 6 is 8. Minus 1 is 7. 7 what?
P.
P. There you go. Look bad at the beginning, but it's really not that hard as long as you take it piece by piece. If you start trying to do too much at one time, and if you don't take things off to the side and work, or show a new line of working on your Education Perfect if you're typing it in, which is fine, then you're going to make mistakes. All right? And there's no reason for you not to pass this just because you're making simple mistakes because you're lazy.
Wait, is
Don't
there another
be
assessment?
lazy.
It's
Well,
funny
no,
too.
but yeah, you're going to need to be able to do
You
it
don't
next
do
time.
pop tests,
So
do you?
there's a. Would I do pop tests?
That's my question.
I think, yeah. And these are your questions.
Please.
Which one of those things would you do first?
The H over 2A.
There you go. There's a division right there. You have to do that first, and then you can combine your like terms. Excellent. Okay? Good deal. Then, so you're ready to do this? Now, I'm going to make this assignment. This is an assignment that we've already had in the past.
This.
If you did it back then it'll come up on your screen, but it'll give you a mark that you've already done it. Okay?
Please repeat.
Right? If not, this is a second chance for you to get it done, you little darling slackers.
You were about to say something different. We can all tell.
I was going to say slackers, then I decided to put little darling in front of it because I want to build you up, not tear you down.
Oh, how sweet.
'Cause,
Calling us
all right.
slackers.
Oh. Called you darlings first.